Hi everyone, John Selway, Vice President of EMEA for Ariaka.
And I'm Stephen Robson, Pre-Sales Engineer for EMEA.
Welcome. So, this is our first chat and we're going to talk today about SASE. So, Stephen, what is SASE?
I'm glad you asked me that, John. So, SASE is a term that encompasses the security and network delivered as a service from the cloud. So essentially it's how the market has moved over the years from distributed architecture to bringing it all together, making it easier to manage, less cumbersome, because as companies are finding they have less and less resource available and less time, and it allows customers then to focus on their core businesses and core competencies.
Cool. And so is it a marketing term? Like, where did the name SASE come from?
Well, the name was first introduced by Gartner. So Gartner, one of their magic quadrants, they made SASE. So Secure Access Service Edge is what the acronym stands for. And that definition I just gave of the network and security as a service from the cloud is essentially that structure. So SASE is not a product, it's more of a construct. It's how people are moving on a journey. There is no finite, you've reached SASE. So there are many, many elements, particularly on the security side. And there are some key elements of security that are a must-have in SASE. So that's secure web gateway, that's securing your internet traffic. It's next generation firewall capabilities, and how that's delivered is something we'll talk about a little bit later in terms of where it's delivered, and being able to manage all of that in the cloud in a single pane of glass. So there are many elements to it, and every single customer I speak to is in a slightly different position on that road to SASE, but everyone is heading in the same direction.
Yeah. Okay, Stephen, so we've learnt what SASE is. Mm-hmm. So there's different approaches to SASE.
Absolutely. So I think that if you think firstly from a vendor point of view, so vendors need to be able to deliver this to enterprises. So there's two main approaches. You've got security vendors who are now building in more networking capabilities to fill in that networking as a service piece. And then conversely, you've got the networking companies who are adding security. Generally, that's through acquisition. So there's been a lot of movement in the marketplace of companies acquiring those skill sets and IP. And then, of course, then you've got the integration of trying to get that to work, particularly with that single pane of glass. So that's the issue. And then moving on from that, how do enterprises consume it? There's two, I guess, general ways of consuming it. And from where we come, obviously, we're a managed service. So our customers take a fully managed service from us. We can accommodate co-management, and that's particularly important in the security space because a customer, an enterprise, want to have control in real time over their security, which absolutely makes sense. The other way of consuming it is DIY. So you've got a networking team historically, and you've got a security team historically. Those are now becoming one team, one larger team. And some companies do manage it internally. But as I said in the opening piece, resources are quite scarce, particularly security resource. So it's a huge challenge being able to manage it in-house. So if enterprises can offload that requirement and keep that to a minimum in terms of their hands-on input. So the network delivered as a service, and there's lots of elements of the Ariaka service that take more and more firefighting and day-to-day things away from those teams, allowing them to focus on the core elements of the security.
Cool. And so it sounds like you've got the traditional security appliance type vendors who are seeing the market move as enterprises want to consume SASE to protect the cloud applications, to protect remote users, and that traditional on-premise device doesn't necessarily do the best job at that. And then you've got another wave of providers who are very much just in the cloud. They don't really do on-premise. And so it sounds like there's advantages to both. So with that in mind, the Ariaka solution, talk to me about the cloud element versus the on-site element, and do you get the best of both, or what does that look like from an enterprise perspective?
Well, you've actually really raised a good point, because the conversation so far, we've been talking about security and we've been talking about networking, and generally that conversation is talking about bricks and mortar sites. Mm-hmm. And with COVID, we all saw a huge change with people working remotely. And that's still the case today. There's some baked in remote working or hybrid working. And that really stretched how you deliver security. So we saw a big move to cloud hosted security. And there are many vendors providing that kind of service. And again, it's either delivered directly from that vendor or through an ISP with a service wrap and a value add to it. That brought the challenge, because then you have your traditional security device on-prem. Then you've got security delivered from the cloud for your remote workers, and a complete mismatch between how those two work. And I've spoken to many customers who find that incredibly frustrating. They have two panes of glass when they want one, so there's lots of swivel chair, and rules aren't applied in the same way. So that is what's driving the next generation, if you will, of SASE, which is moving towards unified SASE. What that means, and it's what we're delivering very shortly, is unified SASE essentially is a single piece of code from a single vendor. So we will deliver a data plane, so where that security element takes place. We will deliver that data plane at the edge, so at the bricks and mortar sites, and at our POPs, so in the cloud, but the same code. So it's a single pane of glass. One rule is applied in both places. So once you define a rule for a user, so that zero trust wide area network, once you've applied a rule for a user, that rule applies regardless of where they are.
It sounds like that's a very different approach from where we're seeing a lot of the traditional vendors who are acquisitive and buying a capability to then bolt it onto a service. But in effect, you've got a provider with different code stacks, and therefore, as you say, you're getting a different user experience depending on where that user is and what they're consuming, versus having this ubiquitous, global, agnostic to where the user is service. That means that effectively, from an IT management point of view, you can globally enforce policy, and that user experience, regardless of where they are, will give them the same access rights.
Exactly. Yeah.
Okay.
Yeah. And the way we've developed our solution, and as I said, it's a single piece of code. The way we've developed it is we've used templates. So within templates, to design rule sets which you can then use as a cookie cutter to put onto different sites, and you can tier those templates, so you can build up templates for not just applications and users but services as well. You can package them together. Mm-hmm. Those templates apply to what we call policy engines. So if you think about the types of security we have, and I mentioned secure web gateway, I talked about next generation firewall, there's URL reputation, DNS reputation, DDoS, all of these different elements of security. And if you think about an old school firewall, you can have a list a mile long of rules. Mm-hmm. And trying to work out which one works or which one doesn't can take hours. And over time, rules, they just become not applicable anymore. So you have multiple rules in a firewall set, some of them contradicting other rules, and it becomes very difficult to manage. By using this policy engine approach, each type of rule is separated. So when you know you want to change a DNS rule, you go to the DNS policy engine as an example. And it makes it a lot easier to manage, and with role-based access you can separate responsibilities. So then you can have access to the security elements just for the security people on your team, and access for the networking side just for those networking people. That's how it's going to work.
So let's talk about performance, and let's get a bit technical. So talk to me about the performance of a packet in this single data plane environment as opposed to some of the other traditional security providers where they've got multiple different engines.
Sure. So the data plane is where we're doing that processing. And as I said, that's very different generally when it's delivered on-prem or in the cloud. But when we talk about the life of a packet, we want to think how that processing is taking place. So we've got a single pass architecture. What does that mean? It means that if you follow, as you say, the life of a packet, it has to go through, in the SASE world, it has to go through the security elements and it has to go through networking elements. And networking elements, your traditional SD-WAN. You think of a packet and you think, is this packet allowed to be routed to this destination? What protocol is it using? Am I applying WAN optimization to it? Is it an SSL packet? Do I need to decrypt it and do some optimization and re-encrypt it? So that's the networking side. And from the security side, you've got your SSL inspection. Do I allow this packet to go through? Do I need to inspect it? For instance, if it's someone's private banking in their lunchtime, I don't want to inspect that. I don't want to do anything to it, just let it go. So that structure I described to you with the policy engines, every packet will only go through that policy engine once. And those policy engines apply to security and networking. So you start at the very beginning of, is this packet allowed? And then once it's allowed, does it meet this set of rules within DNS? Does it meet this set of rules within routing? Is the URL reputation at a suitable score that I can continue? The net result is that that packet, that single pass architecture, that packet is inspected once by each element of the processing engines within the rules of that template, and then it passes through and goes to its destination. So when that SSL packet, as an example, is decrypted for SD-WAN, that's when the security part of SSL takes place as well. So it's only decrypted and re-encrypted once. If you take the acquisitive model we were talking about earlier, companies will have different sets of code. So a packet will move from one device to another and back again. And that SSL example, maybe that packet will be inspected 3 or 4 times with different elements of that architecture. And that introduces latency, so it slows the packet down, but also it introduces risk in as much as error. So misconfiguration, if you're doing it in 4 different places, you may forget to make a change in one, for instance. So having that single pass architecture where you're able to go into those policy engines and those templates and see exactly what you're trying to achieve and doing it in that single pass, that's the huge benefit of unified SASE.
So Stephen, we chatted a little bit about the different approaches to SASE, some of the traditional vendors' approaches, and also this new generation of SASE provider. So let's talk in a little bit more detail about what the differences are about where you enforce policy in a network.
Yeah, that's a good story to talk about really, because over 10, 15 years, the approach to security and networking, to be fair, has changed somewhat. So if you go back to when most people use an MPLS, it's a private network, so some people wouldn't even have security at the edge because there's only one path and it's to the MPLS provider. And then the MPLS provider would provide a secure web gateway or a web proxy server, that kind of functionality. So your internet breakout would be handled by the ISP in their data center somewhere. Then people wanted more security at the edge. So then they moved to what became known as next generation firewalls. And that allowed a lot more detailed security to be done at the edge, and also provided VPN services. And that's where those remote users come in. So then the remote users would typically do a full tunnel. So full tunnel means all of their traffic would be backhauled to that firewall, that next generation firewall, which is providing the VPN service. So that's a concentrator, and it concentrates all of the remote users into one location, and then their internet traffic comes from their laptop in Starbucks or wherever they are, over that tunnel to that concentrator, then through the MPLS network, and out through the secure web gateway. So you can see that's quite complicated, and it's a long path for that traffic to take place. So then people would look to maybe reduce that and have an internet breakout at the HQ where that concentrator is, so they have direct to internet access from that appliance. So it cuts out that leg of going to the secure web gateway of the ISP. But it still impacts the remote user, because you're still tromboning that traffic all the way back to a concentrator and then breaking out and then coming back again. So that made people think about security needs to be closer to the user. And that's where the cloud hosted security came in, because then with multiple POPs globally, instead of backhauling traffic to a concentrator, you're sending it to the cloud, and that security is delivered in the cloud. So once it's gone to the cloud, then that breakout to the internet is closer to the user. But then we get into that issue of the rules being applied there are different to the rules that you're applying on your box in your HQ. So our distributed data plane takes security as close to the user as possible. So when the user is in the office, those templates are applied at the office, and the internet breakout is at the office through the secure web gateway running on our appliance at the office. No need for a separate hardware appliance to provide security anymore. So it makes the footprint in the HQ, the office, or the data center smaller, which consumes less power, produces less heat. So ultimately that's supporting the environment as well. So that's why lots of people went into virtualized environments and stuff like that. So we apply it close to the user when they're in the office. And then when they're out and about, the remote users, the hybrid workers that work from home, then we take their traffic to our POP, because as you know, we've got a global network of over 40 POPs. Each one of those has that security function. So essentially, our POPs become concentrators. So now we can take that user's data when they're in the coffee shop. So we take all their traffic in that full tunnel to the closest Ariaka POP, apply the same rule sets that they would have had in the bricks and mortar site, the same rule sets, same access to applications from our POP, and the internet breakout is from the POP. So that means that you are, where possible, getting the security as close as possible to the user, which is very different from the traditional way of approaching it with an appliance and then a supporting cloud service. So that's where unified SASE is, and that's where the market is going, because the ultimate driver is simplicity and cost. So if you have a single pane of glass, a single place to make changes and apply networking and security, and that single place to have visibility and observability, it means that your staff can focus on projects that affect your bottom line, as opposed to day-to-day humdrum making changes in 3 or 4 different places because you have different vendors.
Okay, so it sounds like, if we're talking to, say, a CIO, there's many advantages to this unified SASE. You've got performance, you've got a single policy enforcement, so consistent user experience, but you've also got the ability to better utilize the resource you've got within your own IT staff, because the deployment of this single solution is easier than managing firewalls, managing routers on site, which will have different firmware, different requirements for you to be maintaining them. This as a service takes away that hassle, and I guess gives businesses a more agile approach to setting up a new site, because it's a repeatable, scalable solution that you can quickly deploy anywhere in the world. The IT staff goes onto the management portal and they can, using the templates, just deploy the rule set that is the global policy, and off they go.
Absolutely, with all their bundled services and applications and rule sets. And this feeds into a much wider field. If you think about what CIOs are thinking about today and what their challenges are, they need to slim down portfolios and services. So we're seeing in the marketplace rationalization of vendor lists, supplier lists. So enterprises want to have fewer suppliers, less throats to choke. They want to streamline processes and be more agile and be more efficient. simplification of day-to-day tasks reduces cost, drives down inefficiencies, and all of these things effectively feed into the total cost line. So if you can reduce those costs, you're having an indirect impact on the bottom line. So it feeds into a much wider picture. You know, we're not the be-all and end-all network and security. There's a lot else going on in enterprises, but this fits, I think, those steps to simplification and rationalisation of businesses.